Alright, so today, by the end of the lesson, we should be able to graph polynomial equations. But before we begin graphing, we need to understand what makes a polynomial equation and also the parts. So I'm going to write polynomial okay. So we have the function f of x, and it equals negative 4x plus 5x squared minus 3x cubed plus 3. Okay? This right here is a polynomial function. And it's a polynomial function because the exponents are whole numbers and the coefficients are real numbers. Okay? Do you guys remember what a whole number is? Whole numbers are 0 and all the positive integers. So 0, 1, 2, 3, 4, 5, 6, all the way up. All the positive integers, okay? Real numbers are all the numbers we've seen so far. Any number that we've seen so far has been a real number, okay? We haven't seen any imaginary numbers. So more likely than not, we'll always be able to check this off. We're just really going to have to check to see whether the exponents are whole numbers. So if we look at this polynomial, we will see that all the coefficients are real numbers and the exponents are whole numbers. Okay? After we're able to determine whether or not it's a function, so we're going to look at this and we're going to determine whether or not it's a polynomial function, we then want to write it in standard form. Okay? So standard form is going to be descending order from left to right. And what dictates the order are the exponents. Okay? So descending means the highest exponent to the lowest exponent. So when we rewrite this, we'll get negative 3x cubed plus 5x squared minus 4x plus 3. Okay? Still f of x. So this function is now in standard form. Okay? Standard form means descending order. Okay? Sorry. And we do it by the degree or the exponents. Okay? That's how we put them in order. Alright? Does that make sense? Okay, so once we have it in standard form, there are now three things that we want to be able to find, or three things that we want to be able to describe. And that's the degree of the function, the type of function, and the leading coefficient. Okay, those are the three things we want to be able to find. Okay? The degree is going to be determined by the highest exponent. Okay? So the highest exponent is the 3. So the degree is 3. And once we write it in standard form, we already have it in order from highest to lowest. So all we have to do is really look at the first term. And the exponent is 3, so our degree is 3. And that's going to tell us the type. Okay? So the type will go like this. We'll have the possible degrees that we're going to go over are going to be 0, 1, 2, 3, and 4. Okay? 0, 1, 2, 3, and 4. If we have a degree of 0, that's a constant. The type is a constant. If we have a degree of 1, the type is linear. 2 is quadratic. 3 is cubic. Sorry, you can't see. And yes, I'm left-handed. And 4 is quartic. Okay? It's quartic. So if all we had was a 3, the type would be constant. Okay? We'd have a constant function. If all we had was a 4x, the highest would be 1. So the highest degree is the x. So as an exponent of 1, our type would be linear. If it was squared, it'd be quadratic. If it was cubed, which it is, it'd be cubic. And if we had a 4 out here, it'd be quartic. 4 is not quadratic because squared and to the 4th power are different. Although they're even, they're not the same. Okay? Quartic. Like a quart of milk. Okay? So the type of this function, what would it be? Cubic, because the degree is 3, so it's cubic. Very good. And the leading coefficient? -3. Okay, so we want to make sure that we put the sign, so whether it's positive or negative, and the leading coefficient is always the first coefficient in front of the x. Okay, in standard form, so it'll always be the first coefficient. Okay, or other words, it's going to be the coefficient with the highest exponent. Alright? So once we understand this, we now want to be able to do this for all polynomial functions. We want to be able to find these 3 things. So I want you to do is, on your whiteboards, or if you're watching this video, I would like you to, what we found here, I want you to do the same thing for this polynomial function. Okay? So here I'm going to give you P of x equals 2x squared minus 3x to the 4th plus 6x plus 1. Okay? So we're now going to work this example, okay? You guys are going to do it on your own, on your whiteboards, or your piece of paper if you're watching this video. So I want you guys to determine first whether or not this is a polynomial function. So is this a polynomial function? Yes. Because the exponents are whole numbers and the coefficients are real numbers. Okay? So now, what's the next step? Standard form. So write it in standard form. When you're done, raise up your board or your piece of paper. Or give me a thumbs up so I know. All I want you to do right now is write it in standard form. Okay, so we should get negative 3x to the 4th plus 2x squared plus 6x plus 1. Okay, this is standard form. So now we want to be able to find the degree. So the degree is 4. Very good. We want to find the type. What's the type since the degree is 3? The type is quartic. And what's the leading coefficient? Very good. -3. Okay? What chart? This chart? No, we just have to be able to find these three things. Here, here, and here. Okay? So now that we understand how to identify a polynomial and how to find its parts, the next thing we have to know is how to determine the end behavior. Okay? Before we can graph, we also have to know how to determine the end behavior. So when I say end behavior, I'm meaning that if we have a function, right? We have a function. How does each end of that function end? Okay? So we just want to be able to see how does this function end. So there's an end here and there's an end here. Okay, there's two ends. We're going to be able to describe that. Alright? So in your warm-up, I had you guys write down the definition of end behavior. And it says that the end behavior is determined by the function's leading coefficient and degree. Okay? So today, we're going to have to understand how the leading coefficient and how the degree determine the end behavior. So, we're going to write down, degree. And we'll also write down leading coefficient. Okay? And if our degree is odd, okay, if our degree is odd, then the end behavior is opposite. Not opposite, opposite, sorry. Opposite. If the degree is odd, then our end behaviors are opposite. Okay? So what that means is our graphs will look something like this. Or our functions will end opposite of each other. So all three of these end opposite of each other. Does that make sense? Okay? Let's hold on a second. So now the other case you might have is if the degree is even. Okay? If the degree is even, then the ends will be the same. Okay, so we'll have scenarios, functions like this. See the difference? Both ends are the same and not opposite. These both end up, these both end down, these both end up. For the odd scenario, this one ends up, that one ends down, this one ends up, that one ends down. So they're opposite. Okay? Now, as far as the leading coefficient, the only thing that matters is whether it's positive or negative. So if it's positive, okay, we read left to right, okay? So the right side, as we read the function, it's going to end up going upwards, okay? So if the leading coefficient is positive, it's going to end up going upwards. So we'll have functions that may look like this. You'll see that all of these end up, the right side will end up going up. Does that make sense? The right side is up, the right side is up, the right side is up, the right side is up. So as you read left to right, the right side ends up. Okay? Now if it's negative, the right side ends down. Okay? Okay? So now, if I give you a function, alright, if I give you a function, we'll call it Bob. Bob of x equals negative 2x plus 3x squared minus 4x cubed. Let's do plus 4x cubed minus 5. Okay? So we have Bob of x. And he equals negative 2x plus 3x squared plus 4x cubed minus 5x. Is Bob a polynomial function? Yes, because the coefficients are real numbers and the exponents are whole numbers. Okay? So we want to rewrite Bob in what form? What's the form called? Standard form. So we want to write it in order, descending order. So the 4x cubed goes first. Then we have the 3x squared minus the 2x minus the 5. Okay? And we want to describe the end behavior of this function. Okay? So the first thing that we want to do is make a quick sketch or get an understanding of what the end behavior should look like. So the first thing we want to do is look at the leading coefficient. Is the leading coefficient positive or negative? Positive. So since it's positive, we know that the right side will finish up. Okay? So we can draw an arrow facing up on the right side. Now, is this degree even or odd? Even. Okay? That is not even. What is 3? No, the degree. So what is the degree? It's odd, okay? So that means that the ends will be opposite. So we can just draw some sort of sketch. It doesn't have to be accurate or necessarily correct. We just want the ends to be correct. So they're opposite. So we started off with the right, and we knew that since the coefficient was positive, the right side would finish up. And since the degree is odd, this side just needs to finish opposite. Does that make sense? Okay, so now we have to describe it. All this is a picture. So to describe this, we will say we need to describe both ends. So we need to work in this direction and this direction, both left and right. Okay? So what we're going to say is, we're going to describe it with Bob. So we're going to say Bob of x approaches. And which way do you guys want to work first? Do you want to work right or left? Right. So Bob of x, as we move right, approaches up or down? Up. So since it approaches up, that's positive infinity. Okay? Because if he keeps going up, that's positive infinity. As x, so we said we're going right. So as x approaches right, and what numbers are to the right? What kind of numbers would end up being right? Positive or negative? Positive. So as x approaches positive infinity as well. Does that make sense? Okay, so that was going towards the right direction. So right is going to be positive infinity. Left will be negative infinity. Up will be positive infinity. And down will be negative infinity. Okay? So now that was just this side, right? We have to also describe the left end. So if we describe the left end, we'll say Bob of x approaches, now the left side, as we move left, is Bob going up or down? Down. So Bob approaches negative infinity, and we got to say what direction we're looking. So as x approaches, and we're going left or right now. Looking at the left side, we're going left. So if we keep going left, we're going to get negative numbers. So as x approaches what? Negative infinity. And this right here is how we want to describe it. Okay? Does that make sense? Yes? Okay, good. Alright. So once we know how to describe the behavior, we then went to, or we now have all the tools necessary to graph. Okay? So we want to keep this stuff in mind, and now we can graph. So when we graph polynomials, for example, we might be given the polynomial, or the polynomial function f of x equals 16 minus x squared. Never mind, let's change this to x to the fourth. Okay? 16 minus x to the fourth. The first thing we're going to put together everything we learned today. Okay? So the first thing we want to do is figure out whether or not this is a polynomial function. It is. Okay? Let's just say the homework, for example, they're probably going to ask you graph this function. Okay? So first thing we have to do is figure out, is it a function? You said it is, which it is. So since it's a polynomial function, we want to do what? Write it in what form? Standard form. Okay? So now this is going to become negative x to the fourth plus 16. Instead of f of x, what can we write? That means the same thing. Y. So this is now y equals negative x to the fourth plus 16. Okay? So when we're asked to graph a polynomial, there's 3 steps. Okay? You want to plot the points. You want to determine end behavior. And then we want to graph it. Okay? So when doing this, we're going to have the xy coordinate plane. And my question is, if we do not have a calculator, how could we plot the points? Yeah, that is a good question. Okay. Would it be possible if we chose x values and found the corresponding y coordinates? Okay. So if I plugged in 0, could I find out the y that goes with the 0? If I plugged in 0 for x, could I find the y that corresponds to 0? Yes. So that means we want, over here at plot points, in parentheses, right table. We want to create an XY table. Okay? So over here at scratch work, we're going to create an XY table. In any of these problems in our homework, they're going to reside around the origin, okay? They're going to be located around 0. So we want to center our table around 0. So we want 0 as a possible x that we're going to plug in, and then we just want to go either 2 units to the left and 2 units to the right. We could go 3 or more, but 2 should be enough. And why did I write 3? That's supposed to be a 2. Okay? So we want to plot all of these points. Okay? So if I plug in 0, 0 times 0 times 0 times 0 is what? 0. And then 0 plus 16 is... So I know that when my x is 0, my y is 16. So I can plot that point. Okay? Now I want to plug in 1. What's 1 times 1 times 1 times 1? Okay? We still have the negative sign in front. So negative 1 plus 16, 15. Okay? So now I can plot 15. Where 1 is. Alright? So now, what's 2 times 2 times 2 times 2? 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So negative 16 plus 16 is 0. What's negative 1 times negative 1? 1 times negative 1 is negative 1 times negative 1 is 1. Okay? So let me put it to you this way. If we were to square a negative number, what happens? Makes it positive, right? Well, anytime it's an even power, it will become positive. Okay, so plugging in negative 1 to x to the 4th is the same as plugging in 1. Okay, so we'll get the same answers here. So we'll get 15 and 0. So we'll plot those points on our plane. Okay? So now that we've plotted our points, we now want to determine the end behavior. Okay, and that's something that we've done. And we do that by looking at that first term, that leading term in standard form. Okay? So how will the right side end? What's our leading coefficient? It's going to end down because the leading coefficient is negative. So we can draw this arrow down. Okay? Now, this is an even or odd exponent. Even. Okay? So the degree is even. So that means that the ends will be what? Will the ends be opposite or the same? Same, because it's even. So we can draw this one down as well. So now we know enough to finish the graph. So we're just going to connect the points from left to right. Okay? And that's how we graph. So for your homework, you're going to be given functions. You first have to determine whether or not it's a polynomial function. Write it in standard form. You're going to have to plot points. And when we plot points, we're going to choose values for our x's. More likely than not, negative 2, negative 1, 0, 1, and 2 are going to be sufficient for every problem. And once you find the points, you're just going to have to use the end behavior to draw the line. Okay? Now, is this an exact representation? No. Okay, it's not. All we want is an estimate, something that's similar or likely to be the function. To get an exact representation, we'd have to plug in the calculator. Because if we did it by hand, we'd be doing it for the rest of our lives because there's an infinite amount of points, and we would keep plotting points until we die. Okay? But that we have calculators for that. Alright? So I hope y'all have a good day. Deuces.